Hello world, my name is Victor Engelmann. Welcome back to this series on professional network design using Linux. Today I want to talk about a topic that I've actually already scratched upon in the video about QEMU, this very popular virtual machine. In that video we used a simple form of networking for the virtual machines. We used network address translation and port forwarding. And I said that these aren't really great ways to do networking. I mean, in many cases they are sufficient and they are easy to use. So yeah, that's what many people use, but they have some downsides. So for example, so the way that this works is when the virtual machine wants to send some data, for example, to connect to some website or something like that, then QEMU will capture that and it will figure out, hey, this virtual machine now wants to send some data. And then it will take these packets and change the source address and possibly also the source port, which is a random number, if you remember from the network packet anatomy video. And yeah, then QEMU will send this packet out. It will receive the response from the website or whatever, and then translate this stuff back and give it to the virtual machine. Okay, and like that, a virtual machine can do a lot of things, but there's also problems with that. For one thing, this only works for IP packets. And yeah, the bigger problem is actually the opposite direction. So what if you want to connect to that machine? Well, you can do port forwarding, which means that QEMU will then open a port and then it will take all the data that's coming in on that port, maybe change the destination port and then give it to the virtual machine, and the virtual machine can answer it. So this is very similar to network address translation, but in the opposite direction. But yeah, the problem with that is, well, this also only works with port numbers. Port numbers are a thing in the TCP or UDP world, so this doesn't even work with IP packets. This only works for TCP and UDP. So for example, you cannot ping a virtual machine like that. And I think that's actually a pretty big problem. And also if you have multiple machines, virtual machines that want to use the same port, like for example, let's say you have two web servers, they would both want to listen on port 80 and 443. But yeah, only one machine can listen on that port at the same time. So you would have to have one of them listen on a different port. And then you have to remember that when you want to connect to that machine, so that you can put the colon port number in your web browser when you access the other machine. And yeah, I think you can do some trickery in the DNS settings, but yeah, this it's not nice. Okay, I think it's reason enough to do this better, and that's what we are going to do today. So first things first, I will disable my Wi-Fi so that I don't have packets going out through the Wi-Fi and making things look as if they worked when they shouldn't. Okay, now in the video about QEMU, I think the last command that we used was something like QEMU system x86-64 with -cd-rom. Then we use an ISO image of whatever Linux distribution as a CD-ROM. Then with boot D, we select this CD-ROM drive as boot medium. Then with -CPU host and -enable KVM, we turn on hardware acceleration. Then with -SMP2, we set the number of CPU cores that QEMU is allowed to use specifically for this virtual machine. And we've used 1 GB of memory, if I remember correctly. Okay. Now in here, if we run interface config, we can see that the machine has the IP address. I hope this isn't too small, but can I increase this? Okay, so we can see here that this machine has the IP address 10.0.2.15. And yeah, 10.0 whatever is not an IP address that my network would give to this virtual machine. Okay, so it must have gotten that IP address somewhere else. And yeah, that's an IP address that QEMU just made up and gave it to this virtual machine for some internal communication inside a virtual network that QEMU runs in the background. But as I said, if I tried to, for example, ping that 10.2.15, nothing, right? So I cannot ping that, and okay, I'll shut it down. That was just the normal networking with network address translation. Now to have bridged networking, that's actually similar to what we did in the routing video. In the routing video, we configured this Raspberry Pi to pretend to be a network switch, right? And then we connected all these virtual network interfaces to that virtual network switch and put them in different VLANs so that this Raspberry Pi then had access to all the VLANs. And what we do now is similar to that. We will again configure this machine to pretend to be a switch. And but what we will do differently is that we will create a virtual network device for the virtual machine, and then it can use that virtual network device to, for the rest of the network, it will then look as if my machine is a switch and this virtual machine is an actual machine inside my network. Okay, so it will be very accessible. It will, this whole virtualization will become very transparent. Okay, it will not feel like virtualization anymore. The virtual machine really feels like an actual machine at that point. Okay, so how do we do that? First I will log in as root, because we will have to run a lot of things as root. The first thing we need to run is mod probe to load some kernel modules, TUN and TAP for tunnel devices and TAP devices. Then we can create this virtual switch using IP link add. So we add a device, which I will call BR0 for bridge 0. That's such a virtual switch is called a bridge. Okay, so and this device should have type bridge. Okay, now we have this virtual switch, but right now nothing is connected to it, so we wouldn't be able to do much with it. So the next thing we can do is we can create this virtual network adapter for the virtual machine. That's done with IP TANTAP add device named tap 0 mode tap. Okay, this virtual network device is called a tap. Now to connect this virtual switch to the physical network device, we run IP link set device my physical network device has this identifier ENP2S0, and down here you already see BR0 and TAP0. So copy that, paste it here. So we connect this physical device now by setting its master to BR0. Okay. Now the physical network is connected to the virtual switch, but we haven't connected the virtual network device to this virtual switch yet. We only have created the device, but it's not connected yet. So to connect that, we run the same command, except we connect tap 0 instead of ENP2S0. Okay, now everything is set up, and now we can start this virtual switch by running IP link set device BR0 up. Okay, now let's look into IPA. Interesting enough, we have a few IPv6 addresses, but yeah, right now this whole thing won't work yet because there's still an IP address on the physical network interface, and first we have to take that away, and we should also give an IP address to BR0, and yeah, we will just give it the IP address that we've taken away from there. So how do we do that? By doing IP address delete. This IP address with /32 from def enp to s0. Okay, it's a bit complaining, I don't know why. But apparently it has worked. The IP address is not on the interface anymore. So let's give it to the bridge now. with a 24 net mask to device BR0. Okay. So the bridge now has this address, but yeah, my host machine now has the problem that from here I cannot do much networking anymore now. So if I try to ping 8888, for example, yeah, network is not reachable because, I mean, I have a valid connection going through BR0 and from BR0 to the physical device that at this point this physical device basically works like a translator from this physical cable into this virtual network that I've set up. So this is more like this physical device is now more like a virtual cable on one end and a physical cable on the other end. Okay, so so yeah, that's a problem. My desktop expects to communicate through ENP 2S0, but that interface just isn't connected in that sense anymore. So we can tell our machine to use BR0 instead. We can do that using IP root at default via 10.1.1.1. That's my Fritzbox through device BR0. Sudo, of course. So if I ping it now, okay, I have network access again now, but yeah, my host machine still doesn't like that very much. It will still complain here every now and then, but yeah, as I said, just use multiple network interfaces and you're good. I forgot to tell you, your DNS lookups might fail after that. So if you need DNS, I forgot to tell you this, but to get DNS running, you can run resolve control DNS bridge 0 and then set the DNS server, in my case 10.1.1.1, which is my Fritzbox, and that's how you would tell your machine to use this bridge 0 also for your DNS queries. Okay, so everything is running. Now let's run our virtual machine again. So let's run QEMU system x86-64 again with sudo, again with -cd-rom core plus current. By the way, that's just this ISO image that I've downloaded and it's in that directory, so no magic happening there. Boot from it. CPU host. Enable KVM. SMP2. Memory 1 gigabyte. Okay, that was the thing we did before with the network address translation, and yeah, it wouldn't even do port forwarding in that direction. That would have required some additional things. what we do differently now are the following parameters. First, we create, or we tell QEMU about a net device on this physical machine, which is a tapped device. We have to give it an ID so that we can reference it later. I'll just give it the ID foo. And its name is tap0. Okay? So this tells QEMU about the physical reality of the host machine. And now we tell it to use that thing inside the virtual machine. We do that by adding the parameters dash device. So we are creating a device in that virtual machine of type virt.io for virtual input output dash net dash PCI. And now the reason why we had to set an ID here is so that here we can now reference it by saying netdev equals foo. Okay, let's see what does it look like now. Running interface config. You see now we have a different IP address. We now have 10.1.1.42. And yeah, that's an IP address that my Fritzbox would give out. So this is coming from the DHCP server on my Fritzbox. So this tells us that the virtual machine didn't obtain its network configuration from QEMU. It has talked to my actual physical hardware, and yeah, my physical hardware has answered it, and because my physical hardware believes now that this is an actual machine. Okay, so yeah, that's kind of neat. Can we ping 8888 from here? Yeah, we can. And yeah, the thing that's really different now from looking from outside the machine is that now we can actually ping 10.1.1.42. You see, now I can ping it. And yeah, every machine in my network could ping this now. And yeah, now you can run this like an actual machine here. You could, for example, run a network server. I will run a netcat with -L for listening mode, -P to set a port. I'll set it to 5000. Okay. And in here I can now connect to that machine. 10.1.1.42, port 5000. You see, I sent hello and it has arrived inside the VM here. Yeah, and there is the answer. So yeah, this virtual machine now feels much more like an actual machine to the rest of the network. Okay, now let's shut this machine down again. Because running QEMU manually like that all the time is a bit difficult. Chances are you probably want to use some GUI for that, and one popular GUI for it is Virt Manager. Okay, this is what Virt Manager looks like. And yeah, let's create a virtual machine in here. I will use a local ISO image. Downloads directory, core plus current. We have to set some operating system here. I will tell it to use some generic Linux machine. I'll give it 1 GB of RAM again, 2 CPUs. No hard disk, we just run it from the CD image. And yeah, a network selection here. If you don't have a bridge, I think the default would be to use network address translation. But I will select bridge device, BR0. Okay, and yeah, now it's already booting. Okay. And now, well, this is a different network adapter we are using right now. So because of that, my DHCP server has decided to give this machine now a different IP address. You see it's gotten 10.11.44 now. But yeah, anyways, I want to direct you to this blue button here. If you press that, then you get to the settings here. And here's this network interface card setting. This is where you can edit this configuration for the network. You see it uses very similar settings. Virtual I/O is the device type. If we run IPA, you can now tell, well, we are running on BR0, but it has created its own tab device called VNet. You see its master is BR0, just what we did manually before. Yeah. Okay, now I don't want to let you go without telling you how to undo all this. Because, as I said, right now the physical network device is unusable for normal purposes. So I wouldn't want to have broken your machine. So how do we undo all this? First of all, turn the machine off. When you close the window in that you've created through Virt Manager, the machine still runs. So that's why I had to manually kill it right now. Okay, now to undo all this, you can run IP link delete device tab 0 BR0. Okay, since we've shut down the virtual machine, that device is also gone. And And yeah, now the network should go back to normal after a while, a few seconds typically. Yeah, let's disconnect and reconnect. Okay, it's gotten its IP address back. The root says it's trying to communicate through ENP2S0. Okay, yeah, let's see if this works. Yeah, this is looking good. Okay, that's all I wanted to show you today. But I want to point out one last thing. In the video about routing, we had this Raspberry Pi where we created all these virtual network interfaces for the different VLANs, right? And you can combine these two things and first create these virtual network adapters on the different VLANs, and then you can create multiple virtual network switches and connect them to these different VLAN interfaces. And yeah, then you can connect your different virtual machines to different VLANs. Okay, I think that's a pretty good idea of like so that the different virtual machines are only accessible in the VLANs where they are needed for whatever reason. Although I think from a security standpoint, I think it makes more sense to just run them normally like we did here, and then have a router redirect the communication, because then the router can firewall the communication again. If you put the entire server into a VLAN, like, I don't know, let's say you put your print server into the VLAN for the printers, then then the printers can attack this print server, right? And when you put the print server behind a firewall, then they can't. Okay, so for that reason, I think it makes more sense to run this on a single VLAN here. But yeah, anyways, that's all I wanted to show you today. If you like this video, like it, share it, subscribe, and see you next time.